G'day, Michael here. This video is basically a follow-up to a video I've got on my other channel. You can see I've got all the videos open from that channel. It's a huge amount of videos. I'm not quite sure, it must be 100 odd. In any case, I've got a lot of technical videos there, so if you want to have a sticky beak at that, feel free. But anyhow, what I aim to do is basically, because I've got the joinery and as well as this other technical channel, there's a video I did there, funny enough, which is the most popular on that, which is about corner unit problems and solutions. Well, I cringe when I look at that video because it was done so long ago, and you know, there's a lot of things I could have done better. Yeah, so this is basically an update on that, and perhaps a different approach. Yeah, so there are a lot of problems with corners, and there's many different ways of looking at the problem. So what I might do is just go to another desktop. Make sure you follow me around. Always in visible workspace. Yep, that'll do. Okay, so I'll go to a clear desktop. I'm using Linux incidentally, so it might look a little bit different to what you used to. But here we go. Alright, so maybe if I start a 2D CAD program, it gives me something to sketch with. And I might also launch a web browser. So let's get Firefox happening. Put it over there. And maybe, where's QCAD gone? Can't see it right now. Oh hell, type it. QCAD. That'll do. No, can't find it. What have I done? Graphics. QCAD, there he is. So, there's been a lot of questions raised. Where's my little screen? I might leave that on top so you're always visible. Always on top. That should be fine. Okay. Right. So there's a lot of hardware out there. There's a lot of different ideas about mechanisms to do the job of doing a corner unit, but there is some fundamentals which is really hard to get off the ground in understanding. So what I might do is I might mock up quickly. Set out green. That'll do. I'll maximise that for the purpose exercise. Verticals. There with 2 shakes. I'll make that length 4,000 might be a better number. Okay, so this might be an accidental tutorial on how to think about designing your kitchen. Now I'm just using a 2D CAD program, and believe it or not, it's a very fast way of doing it. But let's say those lines are 4 meters long. All right. Let's say you wanted to design a kitchen that's about, I don't know, 2 meters by about 3 meters. So I'm just going to make that sort of 2 meters. And these are common dimensions for, I'm going to say a smaller kitchen, but I've obviously, we've had smaller kitchens and large kitchens. So 4 meters by 3 meters. 2 meters by 3 meters, sorry. There we go. Right, so that's the size of the space. Okay, so what is common is for bench tops to be about 600 millimeters deep. So let's just do that, and then that, and then that. Oopsie, that's wrong. Control Z. So this gives us a bit of a feel for a common kitchen size. Now let's just put a couple of rectangles on that to represent maybe bench tops. Now where are we? That one. Rectangle. Just create a new one. Tops. And I might make that a nice fat line, maybe. Okay. And on that layer. So let's say we just make it like a galley kitchen, so you've got opposing sides. Now what that means is, you've got, let's measure that, just to get an understanding of how things work. That is from there to there. Oh, yeah. Drawing settings. Dimensions. Make them about 50 mil so you can see them. Okay. So that would only leave 800 mil between. So having a return, which is quite a common option, just zoom in a tad, having a return, which is quite a common option, would actually mean that these corners would be difficult to use. So with this width of 800, I would actually encourage you to not at all bother with corners, but keep this area clear. So I'll just turn off the set out layer. So you'd actually have opposing, you'd be able to use the full width of each bench top. So let's say you had a sink somewhere. another layer. I'll go appliance. Black. About 0.5 as well. Okay. Let's say I had a sink. I'm just doing this visually, so it's unimportant. Okay, I did that wrong. So let's say your sink is there somewhere and it's got a couple of bowls in it. So arbitrary sinks, you can get all sorts of sizes. Maybe that's your sink. Okay, make it look like a sink. Let's do that. That. Radius maybe 80. Let's do that. Just so it looks a bit more like a sink for you. Make that maybe 30. Okay, so there we've got a sort of a typical sink arrangement. Now the next thing you might need to have is maybe a dishwasher, and I'm going to put that on this side. I'll do that underneath. We'll just leave that as that. Dishwasher. Now dishwasher is usually about 600 ml wide. We need to have, let's go there maybe. Actually there, let's go there. Space at 600, minus 590 so you can see it as a second line. Right. Now just leave that as solid things so we can see that as that rectangle represents something we can't alter because that's the dishwasher. Then we've got the sink space which is going to have the plumbing and so forth in it, so we can't really do much with that either. And then we've got, I might just put the setouts back on. Let's put a couple of walls in just for fun. Actually I might do it slightly differently. Let's do it another way. Parallels on the setout layer. Put some walls in. Offset, I don't know, 110. Assuming the walls are about 110 millimeters thick, just so we can make it look a bit more like a structure that might matter. Okay, so now we're going to draw the walls. That. I can highly recommend this QCAD package as something that's quick to learn and quick to get rolling. Alright, so draw a line that way, make another layer, wall, colour would make it blue. Okay. Now I'm oversimplifying this drawing because there's no point having it any more complicated. That might actually be a wall we fit to. Okay, so turn off all those layers. Wrong. Make them all invisible except for the walls. And then we're going to hatch it. Hang on, got something wrong there. That's what I'm after. Right, do that again. Hatch pattern, angle. I'm going to just make 30 for fun. Okay, scale, I might make it, yeah, leave it at that for the moment, see what it does. Too fine. So I'm going to properties. Maybe out the road for a minute. Scale, I'll make that maybe 10. Okay, so that now represents our walls. Now we have our bench tops. Now I might grab the walls. TA for select all, MB for move back. The tops back on again. Okay, so here's our bench tops. I might make another layer for dimensions because it's important we can see what I'm talking about separately. I might move that 2 dimensions. Okay, so that gets out of the road. If I make the dimensions invisible, we just see the bench tops. So you can see in that situation, really a galley kitchen arrangement is much better than having this corner occupied. But let's say we did draw that back in. Let's turn the set out on. And we go in the bench top layer. Rectangle, that guy. Turn off the set out so it's not so confusing. Okay, so let's say that was our bench top. We have this area here which is very, very hard to use because our access is limited to what we can leave available. Let's put our appliances back on. Okay, so we've got the sink. We're going to have some sort of upright in this space. Again, I'll just oversimplify this drawing. Maybe I shouldn't. Maybe I should start drawing some thicknesses. An important thing with drawings is to realise that every part has a thickness, and all those things eat space. It's very easy to underestimate. I'm just going to make, let's go, I don't know, boxes. Yeah, I'm going to make that yellow maybe, just so we see there's something different. Okay, right, so what is a common thing to do is space at, I don't know, 900, comma, minus 560. Now the boxes are smaller than the bench tops because you have an overhang, you have a door thickness and so forth. Okay, so, what have I just done? Do that. Okay, so there's that box, which is okay. Now we'll do the same over here. But I'm going to do something different on this side. Space at 1100, comma, 560. Okay, so that's happened. Now we need to have some sort of access to doors, etc., or maybe one of these magic corners, etc., but let's just keep rolling with this. From there to there, which is minus 880, so I'll go space at 560, comma, minus 880, enter. So let's say we've got those, they're the sort of box sizes we could have. Now we can put an upright in the center here, but I'm going to do something a little bit different. Let's just do this. If I was to draw a parallel on this box line of maybe 1100, let's do that. There. 1100. That should leave 900. Okay, so we'll actually see something of what I'm trying to explain quite quickly here now. Let's get rid of that. Right, so what I'm going to do now is draw a parallel of 16 millimeters. So I might do it that way first. That way. That way. That way. Oops. Control Z. Turn off everything, so I'm focusing on the boxes. So here we've got just boxes. There's the back of that one. The backs. I'll tidy this up in a second. So actually, Control Z. Okay, so that's that. Let's do some tidying up so it makes more sense. I'll just get rid of that so it's clearer to you. And we have that gone and that gone. So you can stay, doesn't matter. We've got going there. Get rid of one of those because one of them has to be gone. Don't care which one. Okay, so now essentially we've got, excuse me, essentially they're the uprights that we have in those cabinets. Now this is a common size, the 900 by 900. I'll just get dimensions turned back on again. Let's just get some dimensions so we confirm that what I'm saying is not nonsense. Whereas what I've drawn here is 1100. So pitting these two corners against one another. Bear in mind, I'm still suggesting we don't even do this, but this gives you an idea of what the problems are with common designs. Verticals, Okay, so these are our dimensions there. Now what does that do in the front here? What do we get in the way of space in the front? I might just do that there. As you can see, because we have 560, now it doesn't much matter if you're using metric or imperial, you still have the same problems. Whether it's 2 feet or 610 millimeters is irrelevant. But in any case, that's what that is. The depth of the cabinet is 560 because of the overhang. Same here. So now we've got it fairly completely dimensioned, so you can see the differences. And I actually might change this so it lines up with that. So I have some consistency. Alright, so I might make another layer for doors. Let's just get that rolling. Plus face. That'll do. Make that one maybe, I don't know, orange? Cyan. Yeah, orange is good enough. Let's do that. Okay. Right, so what we need first, a common arrangement is to have, draw parallels. Common arrangement is to have bifold doors in the corners. We need that changed to 16 or 18, whatever your door's thickness happens to be. Actually, you can do that. Let's turn everything else off, just have the doors visible. Okay, so there's more to this, but I'm just going to leave it at that for the moment to get it simplified. That guy, where are we? You. And alternatively, that. Yes, now I've got another problem there. I'm just going to set out. No. Boxes. Yes, that's the way. Doors and face, draw parallels. Now commonly have a 3mm clearance between the doors, 1.5. It'll make sense in a second, I hope. And because again, even the space has a thickness, we can't avoid that. So let's turn off everything else again. So the doors and face turned on. Right, so actually, mistake. That. So let's go from there. To it. I'll leave that temporarily. Really? Here we go. Right. Zoom in. This will start making sense shortly, hopefully. That. We need a clearance here too, I guess, so I better do that. This time I want 3. Both here and there. Right, so what we're going to do then. Any shrapnel left over? No, that's good. Okay, so let's turn on the cabinets again, the boxes. Okay, so there's a clearance here for the doors. And this is a typical bifold arrangement. I'll just turn off the boxes so you can see it better. There's the doors, that's the boxes. So let's say this was hinged here and a bifold hinge there. Might just draw a circle to have something to think of it as a hinge. Little circle. Radius, let's do that. make that just so we can see it, maybe 3 actually. So I'm going to do a hinge there, and there would be a concealed hinge. Let's just simplify it by doing that. Whereas on this design, might make that a bit bigger, 20. We have a concealed hinge in this place, and a concealed hinge in that place. Okay, so what I would have with this design is you'd open this door first, and it would be around out of the road. So it'd be rotated out of the way. Let's put the tops back on. So it'd be right around out of the road. This door would have a handle here. Might draw handles. Let's do that for a second too. Oh dear, am I? I'm just going to do something rough. Handles. Magenta, that'll do fine. Okay. Now I'm just going to do something rough, just so we've got a handle, as opposed to no handle. There's a handle there. No handle on the other door. This one here would have a handle on this door. Something like that. Okay. So then turn off everything. Doors and face. Handles. And boxes. Okay, so on the walls. So what we'd have in this space is this door would open out of the road, and that door would open out of the road and give us full access to here. This one here would be hung on that, and it'd be out of the road by having sort of a double folded door here, bifold. You may have seen that as a common thing. So what does that look like as a photo? Let me just find that. Here you can see that type of 1100 by 1100 with a very strong spanning shelf to carry the weight. This shelf is removable, and then it's resting on a cleat on that shelf. So to take both these shelves out, you take the smaller one out, and then you can take the larger one out. It remains adjustable. You can take them out for cleaning, but the important thing is the distance between those two doors is wide enough for your shoulders to span, get between. That way you can actually use the bulk of that shelving. Now when it is narrower, let's go back to our drawing. When it is narrower than shoulders, so that photo is basically of this configuration. When it's narrower than that, so your head can barely get in there, there's no way you can really reach into the back of the cabinet. This kind of design is basically, that's 2/3 useless, and this design is sort of 2/3 useful. There's always a problem with shelves. You've got to reach over things to bring them out. But that brings us to the next point. Now let's say we have a Lazy Susan. Let's just have a look at what's available. Lazy Susan design. Go. So you can do this yourself and have a look at it. Let's just have a quick squiz on that. Now there you've got this design here, and that one. That one. They've all in essence got the same sort of situation, so it looks a lot like what we're looking for. So it's designed for a 900mm cabinet. Okay. Now you can see the design here. The pivot point is well back, right? And that is a common problem. So let's just do that on the drawing. Now, it's not going to give us the specifics, but you can see visually that's about 150mm back both ways. So let's just go back to our drawing here. So 150mm back both ways. Let's draw a parallel. That guy. So that's the pivot point, about 150mm back both ways. I want that on the set out layer, please. Now it has to be that far back so as to give operating clearance for rotation. Now I'll explain why. We'll get our dimensions. I'll leave this on the set out layer because it's kind of a throwaway. So from there to the inside the cabinet is 434, which is about half what you have inside. Let's just try the other side. 434, look at that. So the 150mm both ways is actually an essential dimension. That's not an option for us because that's what is in the middle of that cabinet. So that design that they've done there, centered 150mm both ways. Now just draw a circle so it makes sense. So here's our pivot point for this Lazy Susan. I might just put a new layer there for Lazy Susan, let's say. So we can turn this off, Lazy Susan, and I'm going to put that, there's the center point. And so what we can do as a radius is maybe 420, yeah? So let's just do that. Okay. Now we have to have the frame a little bit back from the doors. Now let's just have a look at their photo. Let's just enlarge that. So you can see that's probably, looking at that, about 30 millimeters in from that line. So let's duplicate that sort of effect. For a line, about 30. Now it's all on the Lazy Susan layers. I'll turn off all the other layers temporarily, so just see the Lazy Susan, and we'll do what we have to do to make it look right. Okay, so trim that. Get rid of that. There we go. And that, and that. And I might just go use a different tool. This, and this. Okay, so there's, in essence, the Lazy Susan design. So it's something like that. So let's just confirm that that's what we're looking at. That looks pretty much the same, yeah? So I've done a fairly good facsimile of what that is. Now let's turn our cabinet back on and let's pay attention to the detail of how much space we actually lose. Now don't forget, that frame will have some thickness, so let's just make that, I don't know, even just 8 millimeters in thickness. So, you know, for maybe the steel framing, whatever. And we've also lost that bit where the where the pivot is, there's the height. And what else have we lost there? There's also the height, like everything needs some sort of operating clearance so it doesn't bang into things. And that frame's what is about 40 millimeters high looking at it. So looking at that frame, you can see that height means you've got to lift things over. Now going back to the photo that I did, yes, we've got that 25 millimeter shelf, pardon me, but that's it, that's the height we'll lose. And the height otherwise you lose is if something is stacked behind something else, you've got to reach up and over it. But okay, you still have that to a large extent with the Lazy Susan. Let's go back to that. You still kind of have to reach, either rotate it around, but you've still got to actually be able to lift things over one another a little bit. It's not quite the same because a portion gets presented to you. Now let's have a look. The portion that's presented to you is just that little bit that would stick outside of here. So maybe I might just, on the set out layer, do that ring again. Where are we now? Talk to me. That. Need to turn that on so we see it. So what you actually have accessible to you is really this bit here that's sticking outside the line. And when you consider the doors will be somewhere around, they have to be somewhere, there will be a bit of an obstruction. Now this design here, it also belies the fact that the hinges will occupy space in here. So we have to make sure that the hinges don't collide with that shelf. Now let's just have a look at their photo to see what they've done. They actually are not showing the door. They're just showing the... See, there's no door shown here. So it's actually a bit of a lie. Because where we want that hinge is pretty much where that part there has to arc around. So we have to do our design differently. We'd have to have the hinge too high, so it would not be ideal for the doors, and it certainly would not be ideal for double hung doors. That won't equal a long lifespan. If you've got a pair of doors hung together, such as in this configuration, where are our doors? Turn that off again. Where you've got this door is hung off, then the handle's on. Okay, so we've got this door is hung off that door. This door will actually be twisting that door. So if you look at any examples, doesn't matter where you look, you don't have to believe me, just look around. You've probably got them in your own home. This door will twist that door. So assuming the hinges are happy with that strain, this door will basically have a problem because that door will twist. In this configuration where one door is opening one way and one door is opening the other way, they're both mounted in what I'd call a normal fashion. See, on both these situations, the doors are basically mounted on a pair of hinges, and so they can handle their own weight. There's no distortion, and the hinges are designed for carrying the doors. So on that sample we had, I might just bring that here. Which desktop are we on? We're on this desktop. Move to the left. Here we go. So let's just go to that desktop. So we've got this guy, I'll put him over here. That guy, put him over there. You can see how we've got the issue with the doors would occupy, you know, the hinges need to occupy a space. And they have to be big hinges. They have to be the 170-degree hinges, which are big thumpers like this. They're big, complicated, compared to my hand. You can see they're quite a big size, right? So we need that kind of bulky hinge, which doesn't really show well in that space. But you can see how it's a large hinge. We can't use a simple hinge. We have to use something that's got a lot of components so as to be able to give that angle. Okay, so this design is not really showing the truth about what you have to deal with when you're assembling it. Alright, so now you can see that kind of design, the pluses and minuses of a Lazy Susan. What else is there? How about magic corners? Corner. Magic corner cabinet. Heavily magic corner. Magic corner cabinet. Let's just have a look. Okay, now there's some groovy, very trendy groovy designs, but again you'll see that they're not quite what you think they should be. Let's just have a look at that guy. One advantage both the Lazy Susan and the Magic Corner has is they present the product to you, whereas this static shelf keeps the product in the cabinet. Okay, now this looks fantastic. Let's just click on that if we can get do that one. Okay, so you see that, how that works. Okay, it's a pretty fancy mechanism, and it's pretty groovy the way they've done it. And I've see they've blanked over labels so you don't have any copyright issues, etc. Okay, so let's see the details of what they look like. Okay. I don't want to use live chat. Chat. Might go back one. Maybe we'll go to the hair flares. Where are we now? No. What have I done? Forward. Magic corner cabinet. We're looking at maybe can't see. I'm looking for hair flare because they've usually got a good range of products. Do this way. HAFELE. Go. Let's just have a look at that. Now, what you see here, now let's look at their plans. And here you get more of the truth. Here you go. Now you can see, designed for, again, around about the 900mm cabinet, which is a common dimension. Okay, so let's just duplicate that. 500 internally, which, let's go back to our design. I might just turn off the Lazy Susan. So we're now going to be talking about the Magic Corner design. Let's see how this works. Admittedly, the Magic Corner design works back to a blind corner. But you can see here there's quite an offset there, which is not actually accurately described here, but visually you can see that's about 100mm. Let's see if I can make that a bit bigger. Okay, so you can see that's about 500, that's about 100. And there's a post there, it has to be structurally sound. And also, we've got various cage designs. You've got this kind of thing going on, and you've got a simple rail. But both cases, there's a limit. If you look at between that shelf and that rail, that's reduced our height. There's also the clearance underneath that is lost, which doesn't show well in this photo. You've got the thickness of the rail and a bit of a mechanism doohickey there. Where are we at? Maybe that one shows it better. You can see there's a bit of a mechanism space here, which it needs, operating clearance. So you lose height, and you lose height again, and you lose height again with the objects. So at the end of the day, you may only get the same volume, just do your sums, doesn't take long to work it out. We're losing about 80mm here and about 60mm there. So in height, let's just go back to maybe QCAD. Let's draw something front on. Okay, so let's set out, they can go back on, boxes can go back on, oh that is on. Right, let's do that. So now I'm going to draw the set out layer, yep, maybe a side view of a cabinet, let's just do that. So this is going to be like a floor, right? Typical kick might be say 150mm, you can make it 100, doesn't matter, it's arbitrary. You're only talking about a small amount. There's that. The bench top height will be nominally 900. Now I'm pretty sure that wherever you are in the world, that'll be much the same because dishwashers. Everything has to clear dishwashers. So if I go, say, 34mm bench top, right, what have we got there? Vertical line, be a wall, right, let's start drawing a box maybe. So what have we got? Rectangle. Well, actually that top will be slightly wrong. Here we go. At 560, 720. Probably can move the bench top up a tad. That's alright. That's a typical box size that I make. Wherever you are in the world, you might have slightly different conventions because of your measuring system. But in essence, it'll be very similar to that. 16. Not everything. Boxes. So floor maybe. Upright. Maybe some kind of rail or a top of the cabinet. It's arbitrary. So that's basically the hole we've got. Now if we do in the set out layer, I might draw maybe, call this one magic corner. Let's do that. Magic corner. Type. Right, let's do that. Okay. So I'm guessing, now this is not an accurate measurement, don't hold me to this exactly, about 60mm for the mechanism. Right. About probably 50 or 60mm for the next rail, for the maybe, I actually might leave it at 60. So that's that space. Then maybe we halve the distance here again. What are we going to do there? Maybe info, point to point. Let's just do that for a second. So that to there. It's 568. Let's take away about 60. So 508 divided by 2. Let's do that. 508 divided by 2. And that should leave 60 in the middle. A little bit of luck. Measurement. Okay. Definitely 60. But we really want to know that space. Because this will help us ascertain the volume we have. Right, so front to back, looking at that drawing. Front to back, let's have another look at that. You need that depth front to back for the post and the operating clearance. Let's do that. Of about 80mm. Let's go back. Parallel. 80mm. There's that. And there'll probably be about maybe 20mm all up on the back. We'll have a look at that drawing in a second. Let's do that again. Okay, it might be even a bit more. Plus a bit. Come on. So we've got clearance lost here, clearance lost there, clearance lost there. So we're losing quite a bit. Let's just go back to our CAD drawing. So we're on the back and we've lost on the end. So our real active volume in section is that, pretty much, right? And in plan view, I'll draw this thing in plan view just to give us a bit of an idea of what's going on. Alright. Corner set out. So 560. Okay, so I'll draw this slightly different way. I'm kind of making a mess of this drawing, but here goes. Okay, so if I make that 900, which is the normal width of the cabinet. Okay. Boxes. Moving off again, boxes only. Okay, so we've got the parallels, 16mm. magic corner. We lost about 80 millimeters there. A plus clearance, it's about 100 millimeters actually. 100. Magic corner. Okay, how much do we lose on the back? Let's have a look at that. I'm estimating between that line and the inside of the box is probably in the order of 40 millimeters. So let's do that. Either way, it won't be much out. And on the end, how much did we lose on the end? That looks again like about 80 millimeters. So let's go back there. So we had 80 millimeters there. Now that box comes pretty close to the front. Yeah, I'll call that maybe 10 millimeters. Okay, so that's where the front would be. 10 millimeters. So look at that again. That opening 395, that's probably about, estimating, about 70 mil from 395. It's about 320, 325 maybe. Let's go 325, just be kind to it. Alright, there's that. Going back to our magic corner again. 395 means it's about 450 to there. About 20 mil between. About, looks like about 40 mil. Certainly the inside of that line to that wall, let's call it about 40 millimeters. 40. And then we had about, well actually probably about the same. Let me just make sure I'm not talking nonsense. So the inside of this frame to the inside of that frame would also be about 40 millimeters. Okay, so that gives us our sizes. Let's go back to there. So our basket size, we'll make that, I don't know, let's do that blue. Cyan even, there we go, because that's kind of more of a visible, exciting colour. Right, there we go. You. Now, what did I do there? Is that correct? I think that's about right. That might be a little bit larger than what it actually would be. Let's just go with that. Okay, so now what we actually have, and I'm going to fill that out as usable volume actually. Might extend that out to there. Let's just do that. Give me a second. Okay, so we have got two volumes available to us. Basket. So one of the baskets, free space is to there. That's actually that basket. Its distance is front to back that. And the other basket is the reduced depth. Oops, what have I done? Control Z. So we have two volumes this area by that depth, and we have another two volumes this area by the same depth. Okay, so let's just do the numbers. Perhaps I might go to cubic meters, maybe. Or perhaps we should do litres. That will work better. Alright, so let's get some measurements there. Let's do litres. This is as best I can do with the information I have at hand. On the other video I had many comments, oh, so-and-so fitting will do this and so-and-so fitting will do that. But I need to dispel that properly with proper information, because it's no point having feelings involved with this. Okay, so let's do our calculation quickly. Where's the calculator gone? There's one. Let's grab it. Basically, that'll be just fine. So to do it in litres, we basically use the number of 100 millimetres or number of decimeters involved. So we've got 4.95 times, 4.94 I should say, to be the same so I don't confuse you, by 2.45 by 2.54, right, which sounds a lot like 10 inches in the old days. Okay, so we've got that. That's the volume of this height with that plan on that basket, and we have two of them. Plus, now just make sure we're not going to get nonsense, we have 4.04 by 4.63 by 2.54 by, it's not going to be right, I might use the wrong syntax, by 2. So I'll just, I'm not sure whether this basic mode will do scientific method, proper mathematical method. So we've got this volume, this is this area, by this height, because we've got 2 in height. So let's go back to our photo. So basically we've got this business twice, and that one twice. So let's look at our side view. So that basket happens twice, this basket happens twice. And I've done my best to, where are we? Done my best to simulate the actual leftover dimensions. Right, now where's the calculator? Unknown. Okay, so I have to do that bit. Use asterisk, but it still shows times. That's a bit weird. No, no, no. Is it happy now? Yes. So we've got 155 litres in there. So alright, we'll open another calculator and we'll go back to my photo. Now that's a simpler design. Now, see, that's all clear space. What you do lose on this, which has to be acknowledged, is if you've got something in front and something behind, you have to lift whatever's behind over the front. So let's just look at that. Our dimensions there. Internally, we've actually got that up here. Is a much more simple layout. So we've got, in essence, this should be 544. I'm going to leave that on the basket layer. Yep, 544. That other dimension is 1068, and that dimension is, no, wrong way. Actually, I'll just do it there. 24. So bringing our calculator to the floor. So this is going to be our floor area. So it's going to be 544, which is the dimension front to back. I'll just do the confirming dimension the other way, so you can see that I'm not talking nonsense. So that is there. So this area here, so 5.44 times 10.68 plus, might just put brackets to be sure we get the right calculation order, plus 5.44 times 5.24. Now we have to get heights, don't we? So we had, looking at this guy, oops, yeah, go down. Now the heights in essence are the same, except we lose the 25mm shelf plus the cleat. Let's call it 40mm. So that height is, then, if that's the case, this less 40. So that's going to be 640. Very simple. Okay, make sure those two are added together. Right, before we multiply it by 4.8. Did I do that right? Let's just look at our calculation. 6, sorry, wrong. 6.48. That sounds better. Oh, that's 561 litres. as opposed to our other number, 155 litres. Feel free to go through those calculations yourself. Do a sketch, whatever it takes for you to understand that. But as you can see, let's just do another calculation, just so we're seeing the evidence properly. That's fine, go the road a little bit. So I'm going to go Control C, Control V, divided by Control C, Control V. So we've got 3.6 times the volume in this versus this. Let's just understand that. 3.6 times the volume. Now that is subject to how you load this shelf and with what kind of items you load it. But at that kind of volume, you could simply blank off that corner, look at a total number, because you've got 3.6 times the area. So if we blanked off this corner completely and threw it away, so you didn't even have that corner access, so you just had front to back shelving, you would still have more volume to store than you have with this. So if anyone needs to comment about various mechanisms, be clear about what actually the numbers are, about how things actually affect volume. An advantage this has is access. A disadvantage it has is it throws away 3/4 of the volume of the space. So very simply, if you were to blank off the corners and have a pair of drawers from this side, a little bit of an offset so they clear each other, and a set of drawers from the other side, you'd have more volume of storage than this. So let's be clear, this is not a space saver. It's really something that kind of sort of gives you the impression that the corner's more usable. And it is not. It's completely untrue. No hope of truth. I've had so much feedback on the other video. I've gotten this so many times over. It's important to understand these do not give you space. They give you some better access, but you get better access to almost no storage. Here you get much more storage and a slightly impeded access depending on how you load it. But that's up to how you load it. If you use this for large items, this is a winner. That brings me to another point. These baskets very much restrict what you can put in them, like very much. This design, if you take out this shelf, you can put an object that is very tall, such as a dehydrator or maybe a mixer with, stand mixer with accessories stacked on it. So this is a much more flexible space and a much more usable space, and just simply a much huger space than any mechanism gives you. It's very important to understand this. Now going back to our Lazy Susan, here we go. This has got the same problem. We're missing again about 60mm because there's a subframe underneath that, and probably about the same sort of number, about 120mm from that floor to there, because you need bearings. You need bearings is some sort of offset. You need access to the parts so you can undo the parts and assemble them and disassemble them, etc. It has to have some sort of frame size, otherwise things fall off. But going back to QCAD, where are we now? We've got that sample up here in the Lazy Susan. Let's turn him back on. Okay, but you can see this area here. Now what have we got here? Let's just get some numbers out of that, because it's important. We are talking real numbers, real facts, real evidence. There's a calculator. I'll make sure it stays on the top. Right, so if I get a measurement here, r squared pi for starters. Yeah, so there's our dimension. And I'm going to loosely call that a quarter loss, because we do have the post. Yeah, we gain a bit here, but we lose a bit there, and that post is missing. Also, to put objects in here, they are very small. You can't actually load them. If you want to put square objects on here, like, storage containers from Tupperware or whatever, they're fairly rectangular. So a rectangular object, let's just draw one in temporarily. Let's just sample container. Let's do that. Don't care what the colour is. Well, I probably could make it a bright, no, not green, won't use green. Red, let's do red. Okay. Now let's just, I don't know, click on there to give me some space. Let's say it was 220. actually. I might go relative measurement. Better do that. That's better. 220, minus 150. Okay. So that'll be, I'm going to say, a mid-range sort of Tupperware container. So you can see that would be quite inefficient for filling a round space. Whereas obviously that kind of space you could fill very tight here. So let's just do that. No. Control C, Control V. So you just fill this thing up with Tupperware containers, we can get quite a few. So even if you wrote off the corner, which you don't have to, but let's say we just did it like that. So it's not just literage calculation that matters, but actually what you can do. So let's just see what we can stuff in here. Maybe let's just do a sample. Does that work? There somewhere. About there. You might, no, it won't go. There maybe. If you're very clever, you might get another one in there maybe, but you can see they're struggling. So just these two shelves. Here I've already got a dozen, and that's flat out getting, what, 7? Yeah, maybe getting 7 on there if you're lucky. Now let's assume the same space, if we disregard it in square, make another layer. So square load the same space. Okay. If we fill the same void with a square load, we can fill out lots and lots and lots. So you can see that using the space in square is so much more productive than using it as a round space. So it's a ridiculous difference. I mean, seriously, it's a ridiculous difference. That did all different colours, which is stupid. Right, but you can see the square space is so much better for storing objects than a round space anyway. So even if the area is the same, you can't use the space the same. Alright, so let's just go back there to our... Turn those guys off. And what else we got? Container, sample container. Okay, so we'll turn off the sample containers. So we've got r squared pi is the area, right? So let's go 4.12 times 4.12 0.3.141, I think. Something. Anyway, that's the number. We can do 20 or 2 on 7. Okay, so we've also got the height, which will be the same as our height for the other calculation. No, it won't. It'll be 254 times 2 times 2.54 times 2. And we've now got to make that about 3/4. So times 0.75. So that means that this circle has been divided, well, it's now about 3/4 that area. So let's just do that. That should be the height. So 2 of them, because there's 2 layers, 2.54. Now I'll just show you where that came from, the 2.54. Both mechanisms have some height at the bottom, and a rail, and a rail. Yeah, so they both sort of end up with this sort of height that you can actually pull objects clear of. Right, so something like that is our number. That's 203 litres, so it's actually a bit kinder than the magic corner. But it's also occupying a different space. Now let's have a look at the drawing of the magic corner. There's a lot to explain. I'm sorry that it takes so long, but that's kind of the way it is. Okay, so the magic corner uses this size box. Lazy Susan uses a half again more box kind of thing. So yeah, it's very clear that there is no chance of there being the same volume involved. This cabinet is, that's a slight error in my commentary here. This 1100 millimeters is a bigger space than that space. So it's twice the, not twice the area, it's about half again more area used of your kitchen to give 5.6 times the volume. That's right. So there's a small error, correction in my my previous comment. So it uses half again more to give you about 5 times the space. So what's that? still say it's 3 times as efficient either way. So in any case, the mechanisms are not holding their own very well at all versus a properly accessible shelf. But going back to my original point, turn everything back on again, turn off the set out. Actually not turn that off, put our tops. Having this line missing, this line missing, Control Z, mistake, make a new thing. So this is the returns. There's so much to talk about here. Returns. Okay. No. Put that onto the layer returns. So this goes back to our original idea. As you can see with this space, this size, you may actually have better volume available and better access to everything if you don't have return. You probably find that it takes about 3.5 meters before it's worthwhile making a corner unit in the first place. Yeah, so I hope that comes up as a fairly clear option. Another situation that may have you flummoxed is if you have a corner pantry. Now let's just draw another corner. How are we going for time here? We've probably been using lots of hours. We've already been at this for an hour, so if you haven't fallen asleep, that's a good sign. Right there. Okay, so let's just do another one. New. Set out again. This time I'm going to talk about a full height pantry that you walk into. Let's just see what's available there. So let's do set out again. Green. Let's go. Again, I'm going to spend less time on making it fancy because just for speed. Let's just say you have a corner, disregarding everything else, and let's say we have bench tops. No. What have we got there? That one. Bench tops of 600 in a corner. All right. Now, 600 divided by, we'll do it, SQRT2, we'll do that. Okay, so if I've got that right, we should be able to do a line from there to there, which is 600mm long. Let's just see if I'm right there. Let's get that right. Okay. Drawing preferences, so you can see it again. 50. So that's 600mm there. 600mm there. So to have a decent width of an opening so you can at least get your shoulders through, you need to have overall 1024. Now for some reason these are commonly made at 900 by 900 or 3 feet by 3 feet, when really we should be heading, if anything, bigger than that, because what happens is the sides of the cabinet have some width. 16 please. I might actually do something like this. Box. Yellow like I did last time. That will do. Okay. So 16mm. The door has some thickness. So I'd have a panel on the outside. Because you might want a face panel on that. You probably have to have a face panel on there, so that's not a probably, it's a definite. Okay, so let's just do that. Turn off the set out so it's less confusing. Oh, one more there. Right, now I tend to make a joined corner here, but I'm going to, just for simplicity, really not do a proper job of this. I'm just going to say that's our door. because the rest is unimportant for us. So there's our door, and really sloppily just go from here to there is our end panel. And obviously if I add some width here to make a nice sort of 45 corner, that makes the door open. So whatever I add here, we have to add in these overall dimensions. So you really are heading for like 4 feet to be doing any good with this stuff. Right, 4 feet being 1.2 meters. Let's clean up this mess a bit. So this is a very poor sample. But I just think that's what we have to do to make this thing happen. Otherwise it'll be here forever. So I'll just do this. That guy. So have some rain. Alright, so that shows you the structure that's required to hold the cabinet together roughly enough. Now, obviously when you go in that door, you need to have some kind of access. You don't want to have the shelves coming this way and that way. You need to have them out of your road. So the best we can hope really there is, I'll just have to shut this window, give me a second. That, 45, is that right? And, I don't know, 400 will do fine. Okay, then I might go for parallel. Now you'll find if you look at a shelf, you have things like maybe jars or glasses or something. That's a big, very big sort of, it's not really glasses, they're like a tumbler. Or you might have something like a cornflakes packet, but they're usually like 200 millimeters or less. There's some exceptions to that. Basically a shelf has to be deep enough to do the job, but not too deep. If you have like a stack of cans, you don't want to have too many front to back, because then you need the height of the can to be able to lift one over the other. So if that makes sense, you've got to have access to whatever you're doing. I'll just put the camera down so I can wave my hands better. Okay, so when you've got one can behind the other, they have to have the height to lift between. So you're better off having a shallower shelf, so it's on each shallow, but more frequent. You actually store more cans and bottles and jars and whatnot, and you don't have one behind the other. So you've got a higher density and height, but a shallower depth. So really the shelves need to be as deep as you need them to be. But let's say we do 200 millimeters, which you'll probably find for a lot of shelves, handling like jars and whatnot, it's actually too deep. You're better off having more of them, maybe at 120, you know, twice as many, less size, gives you the same volume. So in any case, here we are. Let's just tidy up the loose ends there. So let's just do that. So this is a very kind number for the but it gives us some sort of handle. Okay, so there's that there. Right, now when you do that, I mean, you might want to put some rounds in there to make it a bit more pleasant, blah blah blah, but at the end of the day you need to have access to your shelf. So it's about as full as you can make a pantry. Now if you were to use a drawer unit, you can pack a space tight, front to back. Now, I might just do a drawer unit temporarily next to it. We've got setup going on here. Yes, we have. Let's do that. Boxes again, on the boxes layer. That's no distance, we want 560. Let's say width is maybe, how are we going to compare this? Typical drawer unit's going to be maybe 600 mil wide. You can get some narrower, not some wider, whatever. Doesn't matter. Right, so then we need, turn all that stuff off. Now the drawers need some structure, so we do lose material there, so let's draw them in so we're not talking nonsense about that. So you see actually where everything goes. Now the reason why I want to draw these things and waste the time is to show if you're going to make sketches you need to keep these details, otherwise you lose the truth. Now this is what's required for the structure of the cabinet. Let's just clean that up. So that's what's required to hold the cabinet together. Then we need, with the runners I use, if you look on other things in my video channel, you'll see I use a certain type of runner, and they are the most efficient for volume by a mile, much more efficient than the other designs you might have seen around. So the runners have a thickness of 13mm both sides. Then we go back, we need to go 500mm front to back. So on this cabinet design, that's how deep the drawer box itself can be. Get rid of that so it makes sense. Get rid of that so it makes sense. And that's basically dictated by the actual drawer itself. So let's go draw. Make that cyan, so it's a bit easier for you to notice how it works. Cyan, okay, good. So now we'll draw wrong one, that one. So here's the outside of the drawer box, but that's not quite fair, so let's just turn everything off. The drawer actually needs some structure to hold it together. Now typically that means 16mm. Even with the type of material, the type of runners I use, we still can't get away from the fact we need a box to hold it all together. Right, so let's go back a bit. That one. So the drawer realistically internally, I'll leave that layer there, realistically is internally 510 by 468. There's our internal dimensions of the drawers, and that's quite a reasonable expectation. Now with drawers, I typically calculate, I'll just turn everything back on because I do a lot of them. I typically calculate whatever the heights of the fronts are, less 64mm, is what each drawer box is. So let's say you had 3 drawers, which is my typical drawer design. Let's see if I can find one in a hurry. So this is a typical set of drawers that you might have. There's a set of 3, staggering in height. And so how that relates to what we're doing is we have 3 drawers, take away 64. So 3 times 64 off the height. Calculator again. 64 times 3. 3. 128. 192. Okay, so 192 is what we lose in height. The overall height of the box is 720. The 64 does compensate for the top and bottom of the cabinet as well, so it's quite a fair inclusive number. So 528, so it's 5.28 decimeters, not that, this, times 5.1 times 4.68 is the effective volume that's available to you in that drawer box. And that drawer box is underneath the bench height, so it doesn't go floor to ceiling like the pantry does. So we've got 126 litres available actually into the drawer box. Now you can fill the drawers a little bit more than that because there's actually operating clearance between them, and so you've got the advantage that where the drawer box finishes and where the next bottom is, there's a little bit of clearance. So you can make them a little bit bigger than that. We might even get as much as 130 litres in that. Okay, so let's just have a look at how we try and compare the volume. I mean, we've just done the calculation of, what do we say, 126 litres for this drawer unit. It's a bit trickier for the pantry because there are, I'm going to say, incalculable losses. Okay, so I've done a reasonable effort of producing a pantry. As you can see, there's a lot more shelves in there than most people would put in. But let's assume that's what we did. So it's pretty densely packed. Now the problem we have is when we have like a can, I might actually cancel that. Might make the carcass invisible now, just so we can see the actual shelves. So looking inside the cabinet, I might actually get rid of these guys too, so we're not looking at them. For a second. Okay, so here are our shelves. We have obviously the floor, plus these further 6, so that'd be 7 surfaces. But if we have a largish container, let's say that's, I don't know, about 200 high, and maybe 200 deep, and maybe, I don't know, 80 wide, which is maybe like a cornflakes packet or something like that. Put it maybe, I don't know, there. Okay, so when you have large objects like that, if you were to put one on this shelf and one on that shelf near the corner, you lose the corner. So the shelf is not as big as you think it is. Like you might think you can pack it solid with large objects like that, but you actually can't. So in the corners, and we have corners here, corners there, so that's kind of lost in the corner, because you have a corner, like you have a box full of corners, which is our fundamental problem in the first place, is corners. And let's say we do something else, maybe like a can. To get that can out, if there's a row of cans, you have to be able to lift it up over the front can. So smaller objects, you'd need to have a shallower shelf to be able to reach every can, and you could make the shelves more frequent. So with that design, you kind of lose half the space there too. So we can't really count them as 200 millimeters or 250 millimeters that height. We can only sort of count them as half that if you want to use how do I express this? You can't just have, the height that you see on the shelf and the depth you see on the shelf and think of that as what you get. We lose corner space here, all these corners, because anything you pile around either side of that corner stops you from getting to the corner. You can't use the full height if there's anything front to back, one behind the other, that you might have to access. If you use a full-size box, you lose the corners even more. If you use smaller objects, you lose the height. So it's really kind of only about half what you think you get here. Now let's assume we have 7 surfaces, because there are 6, 1, 2, 3, 4, 5, 6, 7. Actually, let's even call it 8 surfaces. Let's be really kind. So let's get ourselves a calculator here. Actually, get another calculator. And drop that down. So let's get this guy handy. So let's say we've got 8 surfaces that are, well, I'm going to count the height as the same as this can, 110, because it's only half usable. So it's 8 times, so it's a number of shelves, times the effective height. If they're full with smaller objects, you need to have half the height free. So let's go 1.1 decimeters. The width left to right, I want to use my hands, which doesn't quite work. The width left to right, what are we going to call that? A metre? So it's going to be 10. And of course, we've got the same coming the other way. Because of the corner loss, it's hard to calculate what they are. So let's times 2, because we've got one going either way. Right, so that's my best attempt at trying to work out the usable volume in that pantry. How about we change that to 1.1. Sorry. That is 11, silly sausage. I forgot. No, 1.1's a height. That's right, 1.1 decimeters by 10 decimeters by 8 shelves, and obviously returning as well. So that's 176 litres, which is bending my brain. You want to see that there's more there. But let's say I'm out by a factor of 2. Let's double what I just said, just to make sure. So 352. So jump in and correct me in the comments if you see that this calculation is wrong. So, well, let's just get some measurements that just to make sure we understand that we're talking the same thing. So this, from here to here, is 668 millimeters. So we've got the same there. So saying it's a meter is actually it's very kind. This space is mixed use because the more you put here, the less you can see there. So you could argue that perhaps just having that shelf on that shelf is the best way of using the space and forget about that, which you still end up with a 1 meter by 1 meter space. So yeah, I don't know. That's the best way I can calculate it, and the fact that you have to reach over something if you make it shallower means you halve the height. If you make the shelf shallower, you can put the shelves more frequently, but they're only half the depth. So either way, somehow or other, it's about half what you think it is, and even doubling what I say, we get 352 litres. Now, what did we say that draw unit was? Where are we now? Not there. That one? We said that's 126 litres. Now, isn't that bending your brain? So, 126 litres was nearly the same as what I think is a fair calculation for the volume of your actual usable space in this cabinet. So, two of those units, which are 126 litres times 2, let's say. Oh, what am I saying? Actually, I'll get another calculator. So 126 times 2. So 2 drawer units is 252, which is handsomely between these two numbers. So you could safely, comfortably argue that 2 drawer units holds more than that pantry. And it would be very hard to refute that calculation. Try these calculations yourself. Don't believe me. Think about how you can access the corners. Think about it very fully. Don't be dismissive and just think, oh, it's the volume. No, not exactly, because you're full of corners, and the way you access the objects takes away from the volume you get. So yeah, it's a tough one, but my guess is these 2 drawer units are a match for the whole pantry. So let's look at them in 3D space to see what we get out of all of that. Unblank all objects. Okay, so these 2 drawer units, which is the mock-up of what that drawer unit I did in the 2D CAD, plus these overheads, definitely hold a lot more than that pantry. And if you look at the plan view of the pantry in, say, a normal kitchen, where are we? I missed it again. Okay, where are we? Back here. Wrong unit. That one. Okay. So the 2 drawer units, which would occupy about this space here, hold 2 drawer units plus overheads hold more volume than that pantry unit. Plus, you get bench top. Yeah, I'm beside myself trying to explain that to people, and that's why I've gone through the trouble of making this video. So let's just, I'll go back there again. Yeah, I'm beside myself trying to explain this. I've had many comments on the other video trying to refute this, but that's why I've spent the extra time on these calculations. It's very important to understand these calculations are about as good as you can do, and if you can think of a better way of working out this volume, okay, go away. If you can think of a better way of working out this volume, feel free to demonstrate it to me, make it clear that what you know is better. But really, the volume that's available in a pantry like that is very poor compared to the amount of space it takes out of your kitchen. Plus, you get no benchtop where that is. So these 4 cabinets here exceed the storage volume of the pantry. Plus, they give you bench space. Plus, everything's much more accessible. Plus, you don't have to walk inside a cupboard to get there. So really, these corner cabinets are a crazy luxury that, well, are they a luxury? That are very misleading. So corner units are a tricky thing. Yeah, I'm at my limit as to how to explain it any better. And you see the mechanisms only give you a presentation of the product that you might be storing, but they do not give you back any volume. And I'm kind of going around in circles, back to the point where we have, where's that photo gone? That guy is a good solution for an underbench corner unit. And going back to, 2D, where are we now? Going back to this guy, a kitchen that's maybe only 2 meters wide may seriously be better off with no corners, just leaving 2 opposing walls. Okay, now I've gone through the volumes, how to calculate the volumes of what you can use, but I'll just make sure this camera's doing its thing, always on visible workspace. Okay, so, but there are a few different approaches one can take when dealing with corner units. Now I've shown you the simple corner unit, and I've also shown you the option of not using a corner. Now this kitchen is absolutely tiny. We were stuck with having to use this return because that was where the sink was. Let's just check that I'm actually recording it. So the sink had to be in this space. That's a window. The stove is there, so basically we needed to use all three spaces because of historical reasons, and there physically wasn't anywhere else to go. So here you have a very tricky, it was a bundle of trouble basically, this kitchen. Now what you can see looking from above, this bench top here I made quite deep, whereas the others were 600. Right, so I'll just take that bench top off. Right, now drawers, I can make very, very deep drawers. You can get runners up to 750mm deep, so drawers can use deeper spaces, and you don't have to crawl in underneath them like you do a shelf to get out, whatever's in them. So having drawers that can come out all the way means you can use deep cabinet spaces without any grief. Now this corner was very difficult to use at that depth, so what we ended up doing was making this side shallower, where I did plan view, getting this side shallower, that's the two shelf spaces, and then having door access to the other side. So put that bench top back on. Okay, so these two doors, so we'd have a set of shelves. I mean, there was adjustable shelves in that space as well, but then we also had access to the corner unit on that side, but then I've got the other corner unit at the other end. So we had, this is the best solution I could come up with, giving the very tight design constraints for this kitchen. So you can see how that worked. I might just change the viewing so it feels a bit more natural. Okay, not so weird. Right, so that there is as accessible as I could make it given the constraints. Obviously whatever we could move this across to the left gave us a more usable drawer arrangement. The sink unit basically was dictated by the bowls and the plumbing, so there's not much I could do there. This side here I made it shallower so that you could reach into that space without having to get your head in there so far, and then used the opposite side from the outside of the kitchen. And that kitchen is working very beautifully. It was quite a successful result for how tight that space was. Another trick was, obviously you need a range hood above a stove. This was an upright stove, so it had the cooktop and everything on it. The microwave was mounted in a sort of a semi-dropped down overhead, so that it wasn't on the bench space. So this freed up so much bench top with this the way it is. You can imagine a corner unit. Well, that was a fridge in this. Zoom out. There was a fridge in this space. Yeah, so it was a very compact kitchen, serving a 2 or 3 bedroom house. So I was asking a lot of that space. In any case, that's about as much as I could squeeze into that tiny space. So you can see there's a couple of solutions there for using corners. Where you've got an opposing side, obviously access from the other side eliminates that problem of corner access. Alright, so there's that. Yeah, so that's about all I can pass your way. Feel free to like, share, subscribe, ask a question, leave a comment.